Here we're being asked to simplify each of the radicals. I always start by making a list of sort of the key perfect squares and perfect cubes that I might encounter. So for example, I would have 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and again I'm getting this by 2 times 2, 3 times 3, and so forth. 6 times 6 is 36, 7 times 7 is 49, and so forth. Now I also have perfect cubes. So here I have cubes, and I have 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. I might end up going higher than that, although there's not a really high probability of that. There's also fourths. That's another one that we could work with. But when I'm looking at these, I only care about numbers from each of these lists that goes evenly into the number under the root. So for example, on the first one, I have that this is a square root. So if you don't see a number like you do here, it means that it's a 2. So it's a square root. And you need two numbers that multiply together to get 64. So in this case, that would be 8 times 8. So 8 equals the square root of 64. Okay, now 16 and x to the 4. I can use the product property to help me with this by separating these. So I have 16, and I have the square root of x to the 4. So the square root of 16 is 4. And remember that there's an invisible 2 here. So what you do is you divide the exponent under the root by the root. So in this case, it would be x to the 4 divided by 2. So my final answer would be 4x to the 2. All right, so both of those were square roots. Now we're moving to a third root. So we want to figure out what number do we multiply 3 times, or 3 of them together, to get 8. Well, in this case, it's 2 times 2 times 2. So I'm going to do the cube root of 8, the cube root of x cubed. Well, the cube root of 8 is 2 because 2 times 2 times 2 is 8. And then I do x to the 3, that's the exponent on the inside, divided by the root. So my final answer is 2x to the 3 divided by 3, which is 1, or 2x. Either of those are perfectly fine for the answers. All right, let's move to the next one. So I'm going to do the same thing and separate these. I have the cube root of 27, the cube root of b to the 6, and the cube root of c to the 9. Now the cube root of 27, notice over here I have that 27 is a cube root, which is 3 times 3 times 3, or 27 is a cube, so the cube root of 27 is 3. That's what that becomes. Then I get b to the exponent of 6 divided by the root of 3, c to the exponent of 9 divided by the root of 3. So to simplify that down, I get 3b, well 6 divided by 3 is 2, and c to the 9 divided by 3, which is 3. So this is your final answer. All right, here's another one, and this one doesn't have any numbers. We're only dealing with variables. So I'm going to go ahead and rewrite as the cube root of x to the 12, cube root y to the 6, and cube root z to the 9. Oops, z to the 9. Now I divide the exponent in the inside by the root, so I get x to the 12 over 3, y to the 6 over 3, and z to the 9 over 3. Now I need to simplify, and I get x to the 12 divided by 3, which is 4, y to the 6 divided by 3, which is 2, and z, which is the 9 divided by 3, which is 3. So this is your final answer. Okay, now the last one here has a fourth root. This is the first fourth root that we've dealt with. So I've got a list here of squares. I've got a list here of cubes. So now I'm going to think for a moment, what perfect fourths do I know? Well, that's where I multiply a number and have 4 of them. So 2 times 2 times 2 times 2, for example. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is actually a perfect fourth. So I'm going to do the same thing. I'm going to separate these. The fourth root of 16, the fourth root of b to the 8, and the fourth root of c to the 4. Now, as I showed up here, the fourth root of 16 is 2, because that's the number that I repeatedly multiply to get to 16. Then I get b to the 8 over 4, and c to the 4 over 4. My final answer is going to be 2b to the 8 divided by 4, which is 2, c to the 4 divided by 4, which is 1. So I can either include the 1 or leave it the way that it is. So this is my final answer. Here we're going to continue simplifying radicals, but this time we're not necessarily going to have radicals that simplify out evenly. So I still care about my list of my perfect squares and my perfect cubes. So I have 4 to start. 2 times 2, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and I could go ahead and continue if I wanted. Now thirds, I have 2 times 2 times 2, which is 8, 3 times 3 times 3, which is 27, and I could go on there as well if I wanted to. So when I look at this first value, square root of 50, I want to look and see, because it's a square root, is there a number that goes evenly into 50 from this list? Well, the answer is yes. So I get equals the square root of 25 times 2. Now I can rewrite that using the product rule, which is the same as the square root of 25 times the square root of 2. Now, what is the square root of 25? Well, that is plus or minus 5 square root 2. All right, so now I'm going to move to the next one, which is the square root of 32. And again, because it's a perfect square, I care about my list of squares. So 4 goes into 32, but there's a larger number that goes into 32 as well, and it's 16. So the bigger number that you pull out, the fewer steps you're going to have to take. So I'm going to go ahead and use that one. So I can rewrite it as the square root of 16 times 2. Now I separate those and get the square root of 16 times the square root of 2. What is the square root of 16? Well, it's plus or minus 4. And then you have the square root 2 left over. So that is your final answer. Okay, the next one we're going to do has a cube root. So now we care about our other list. Okay, so for 16, do either of the numbers in our cube root list go into 16? Yes, 8 does. So I can rewrite it as the cube root of 8 times 2. And now I split that apart, and I get the cube root of 8 times the cube root of 2. Again, the cube root of 8 is 2, so that simplifies down to 2, and I'm left with the cube root of 2. So that is your final answer. Okay, and one more. Again, we've got a cube root. So is there a number in our list of cube roots that goes evenly into 81? Well, 27 goes in evenly, so I can rewrite as the cube root of 27 times the cube root of 3. Now the cube root of 27 is 3, because 3 times 3 times 3 is 27. So that's what this becomes. And then what's left is the cube root of 3. So I'll rewrite that, and it's 3 cube root of 3 as your final answer. Now we're simplifying radicals, but this time we have a combination of numbers and variables. So we're going to do the same thing with our list of perfect squares and cube roots. So I've got 4, 9, 16, 25, 36, 49, and so forth. Perfect cubes, I have 8, 27, and again, you can continue those lists longer if you need to. Okay, so starting with the first one, it's the square root of 8x to the third. So, does 8 have one of the numbers in my square list? Yes, 4 goes into 8. So I get the square root of 4 times 2, and then the square root of x to the 3. So this part simplifies out to 2 root 2. Now I'm not done yet because I need to simplify out my exponent on that variable. So I can rewrite that as x to the 3 over 2. And remember that it's 2 goes into 3. Well, 2 goes into 3 once. 1 times 2 is 2. So I'm just doing a mini long division problem here with a remainder of 1. So the way that that final answer is going to look is I have an exponent of 1 on an x on the outside, so I get 2x, square root 2, which is this 2, and then my remainder here says that I have 1 remaining x under the root. So my final answer is this. Okay, so now let's go ahead and do the next one. It's another square root, so I care about this list of squares. 9 goes into 27, so I can rewrite the number as the square root of 9 times 3, which becomes plus or minus 3 square root 3. I just paused because I realized I didn't include my plus and minus here, and it's a square root, so there should be a plus or minus 2x, square root 2x there. Okay, so I'm done with my numbers, and now I need to move to my variables. So I get x to the 7 over 2, and I get t to the 3 over 2. Okay, so again, to figure that out, 2 goes into 7 how many times? It goes in 3 times, or we can do our mini long division problem. So 2 goes into 7 3 times. 3 times 2 is 6. I subtract, and I have a remainder of 1. So the exponent on the outside with the x is the 3, and on the inside is the 1. Okay, for my t, I get 2 goes into 3 1 time with a remainder of 1. So I have plus or minus 3 on the outside. And then I have for my x, an x to the 3 on the outside. Oh, I'm going to have to erase my list of numbers here. I haven't given myself enough space. So let me do that. Okay, so again, the x on the outside goes with the 3, and then the t on the outside goes with this 1, and then square root what's left. Well, I've got a square root 3, so a 3 goes inside. I have a remainder of 1 on an x, so 1x goes on the inside, and a remainder of 1 on the t, so 1t goes on the inside, and that is your final answer. Okay, let's try this again. And this time we're dealing with a cube. So we care about our cube list, which actually we still have here. So, do either of those numbers go into 32 evenly? Yes, it goes into 32. So I can rewrite that as the cube root of 8 times 4, okay, which becomes the cube root of 8 times the cube root of 4. So that ultimately will be separated. The cube root of 8 is 2, so that would become 2 cube root of 4. So that's my final value for the number. I'm done with that now. All right, now I need to find my z to the 7. So this time I have z to the 7 over 3. So I want to do 3 goes into 7 how many times? Well, 3 goes into 7 twice. 2 times 3 is 6, with a remainder of 1. So the value that's going to go on the outside is z to the 2, and on the inside is z. What I'll do is just start writing the values on the outside. So I know I have a 2, and now I know I have a z to the 2, and I'm not going to worry about under the radical yet. I still have my y to figure out, which is y to the 4 over 3, which is the same as 3 into 4, goes in 1 time. 1 times 3 is 3, so I have a remainder of 1. Okay, so I have one y that goes on the outside, and then I have the cube root of, here's the numerical value that's left, and then for my z, I have a remainder of 1, so I get z. And for my y, I also have a remainder of 1, so I get y underneath. So this is my final answer, and it's a cube root, so it's just going to have one sign. It's not going to have a plus or a minus. Okay, last one. We care again about the cube root, so we're going to rewrite that number, and we get the cube root of 8. Just because of space, I'm going to skip the step of writing them combined like this, and I'm just going to go straight to separating them. So the cube root of 8 times the cube root of 3 takes care of my 24. So down here, cube root of 8 is 2. That's where I'm going to keep track of what goes on the outside. So I'm done with that, and I still have a cube root of 3 that I'm going to have to include, but I'm not going to do that yet. Okay, so I have x, okay, right here, to the 12 divided by 3. Well, 12 divided by 3 is 4. So there's nothing left. There's no remainder. So there will be no x's under the root. So I can just go ahead and put x to the 4th on the outside. And now I'm done with my x to the 12. Okay, the next one I have to do is my y. So I get y to the 10 over 3. Well, that is 3 goes into 10 3 times. 3 times 3 is 9. Subtract those, and I get a remainder of 1. So now on the outside, I have y, and again, this tells me the exponent on the outside, y to the 3, but I need to not forget the remainder. That's going to ultimately end up under my root. Okay, so I'm done with my y, and now I have z to the 31. So z to the 31 over 3, well, 3 goes into 31. That's 1 times 3 is 3. 0, bring down the 1. 3 goes into 1 0 times. 0 times 3 is 0. So 10, remainder 1. So again, on the outside, I have z to the 10. And now I need to go back and put all of the stuff that belongs under the root. So I have root, cube root, 3, that's the first value. The second value is my y and the remainder on that, so there's just one y. And then my next value is the z, so z with the remainder, and the remainder was 1. So my final answer is 2x to the 4, y to the 3rd, z to the 10, cube root 3yz.